Hello Snowflake engineers and welcome to the video. If you don't know me, I am Sujit Nair, a cloud data architect. I am also a Snowflake Snowpro certified professional. In today's video, I will be covering certification question related to Snowpro. Let's begin.
What does the function approximate similarity do? I will give you a couple of minutes, a couple of seconds to try and come up with the answer. In case you need additional time, please pause the video. And the right answer to this question is returns an estimation of similarity of inputs based on their mini hash states. Now, let's try and spend a minute trying to understand what the approximate similarity function does. So the role of the approximate similarity function is to compare two data sets. And for our requirement, we can consider the data set to be tables. So the approximate similarity function is supposed to compare two tables and give you a number between 0 and 1 to indicate how similar or dissimilar the data sets are. So if the two data sets or tables are exactly similar or exactly identical, then the value that we will get from approximate similarity would be 1. And if they are completely not similar or completely dissimilar, then you would get a value of 0. So a value between 0 and 1, you could get any value between that two to indicate how similar or dissimilar they are. So if a data set they are somewhat similar, then you could get a value of 0.5 or zero point 0.6, indicating of how similar or dissimilar they are. So now let us jump into a demo to see how it works. Now to begin with, I'm going to create a database called target. I'm also going to create a table called orders for the purpose of this demo. I'm also going to create another orders table for the purpose of this demo. So now I have two orders table, orders A and orders B. Now approximate similarity has a requirement that the input to it should be in the form of mini hash. So let me repeat that. Approximate similarity has a requirement that the input provided to it should be in the form of mini hash. Now we can calculate the mini hash of a table by using the mini hash function and then putting the rate at which we want the mini hash function to work. The higher the value, the more accurate, and star so that it considers all columns in the table. So now over here we can calculate the mini hash for orders A. As you can see, the mini hash is calculated here. And when we run this query, we will get the mini hash of table B. Now, the mini hash for table A and table B is going to be exactly the same because I created table A and B from the same data source. So if I apply the mini hash function on orders A, orders B, and then feed it to approximate similarity, because these two tables are exactly the same, the mini hash generated will also be exactly the same, and the answer that is returned from approximate similarity would be 1, indicating that both the tables are identical. Now, in order to demonstrate that approximate similarity will give us an answer less than 1 when the table value changes, what I'm going to do is that I'm going to update certain fields and values in the table to make the two tables different. Now I have a column called order status that is present here with the value f, and what I'm going to do is that I'm going to update the order status to x wherever the order table is f. So we have had about 729,000 rows updated, and now the orders A table and the orders B table are different because of this update. Now I'm going to rerun the approximate similarity function, and now we should see a value which is less than 1. So now this indicates that there is a 40% similarity between orders A and orders B table. So the use of this table is that if you are trying to compare extremely large tables, this will help us reduce the amount of compute we will need if we use other functions like set operators like minus and except and all those.